Hello friends, welcome back to the bench. Today, as you can see, we have a very ingenuitive design that I've seen on YouTube. I'm not going to show the actual video because I don't want to route traffic to it, because this is a very bad idea. And you can immediately see why. And I wanted to analyze it actually in the simulator to actually see what's going on when you connect the circuit like that. And I'm gonna try to fix it, or at least, at least try to fix it. So this is the circuit that is suggested by this person. This is supposed to be I assume, the indicator. Maybe like a test probe that you put in the outlet to see which wire is line, which one's neutral. Maybe that's the idea behind it. Maybe the idea is that just for that LED to be built into the outlet and just showing you that the voltage is there. Maybe. Either way, it's a very not very bright idea. You could actually hurt yourself. You can see the voltage on the diode over here, right? Let me show you because this is designed for 220, so the amplitude is roughly around 300 volts, maybe a little less. Doesn't really matter. Let's go 300 even at 50 hertz. I think that's the European frequency. And now we're pushing that voltage to the resistor, right? 300, negative 300, and to the diode. And on the diode, if we zoom in over here, even more so, even more, we have roughly 2.5 volts. So the resistor was kind of calculated roughly correctly for this diode. But the problem is, how do I zoom it out completely? That the voltage, the reverse voltage, goes all the way to negative 300. It goes all the way to negative 300 because it's AC, right? So that diode will burn after the first cycle. Maybe it'll explode, hard to say. And let's check the current on the resistor. Burn ups, not this one, this one. So the current is fluctuating to around 3 milliamps. So that's okay. The diode can handle that. Most diodes can handle up to like most diode, depending on the power of the diode, right? The most common are a quarter watt. Now I decided to change the circuit to this, and I'm not sure whether this is actually correct or whether this will work. This would work correctly. Probably not, but at least it is a little bit closer to what it probably should look like. So I added the diode and the 47 microfarad capacitor. The resistor stays the same, and I also added a Zener diode, 4.5 volts, to protect the LED. Although probably 4.5 volts would be too much for this diode either way. So if it actually goes to 4.5 volts, then before the Zener diode starts dropping the voltage, the LED probably would be broken at that point. So that produces, not here, here. Let's click that again. That raises the voltage on the capacitor to roughly 2.5 volts, and it stabilizes after less than 100 milliseconds. 0.200 would be here, even less than that. And let's see the whole thing. You can barely see through here, yeah, you can barely see when it's actually raising. What happens in the circuit? Circuit's pretty much very simple. So first, depending on which phase we're starting, positive or negative, which half of the wave. So if it starts with negative, then the capacitor starts charging through the D3 Zener diode and the R2 and R1 resistors. The other way around, if it starts from the positive half wave, then it charges through D2, no resistor. Perhaps the resistor should be there, or maybe the resistor should be after the R1, and the diode also should be after the R1. So the R1 would be the first element. Maybe that would have been better, but you know, I'm not a designer, circuit designer, right? But that's roughly what it is. And if you come across this video, well, there's like 30 something views on it in like 2 years or something like that. So it doesn't get a lot of traffic, and the video is like 20 seconds long, and that's all that the guy shows you. I don't know if the guy actually tested this circuit. I would definitely advise to test this stuff before you start sharing it on YouTube, because someone might get an idea that this is actually a working circuit. And imagine that you know nothing about electronics and you see the 100K resistor, you don't know what it is. Maybe you assign some not understanding how something works might give you a false confidence that maybe this resistor is some kind of magic device that drops the voltage, or you know, who knows. This looks legit. This looks like someone actually, you know, knows what it's talking about, but no, they don't. They don't. Don't do it. Don't do it. You could hurt yourself doing this. And it's absolutely, what is the use of this device even? I don't see any. Well, anyways, just wanted to show you guys this because I found it funny on one hand and really disturbing on the other hand. Why would you share something like that? Why would you want to do something like that? On live wires, the 220 volts, actually the voltage now is 230 in Europe. I don't know if this is video from Europe, or maybe some places in the world still using 220, but the European standard is 230 nowadays. It used to be 220, yeah. All right, thank you very much for watching, and I'll see you guys in the next one.